So we want to do number 32 in 8.5, which is one of these I through everything problems. So I need to use this picture, with labels on the y-axis, which I have poorly reproduced from the book, to answer A through J. So what's question A?
Determine the vertex.
Vertex? Okay, so where's the vertex?
-1 and -4.
-1, 4.
Oh yeah, I can just read that off, right? So it's this point here. That looks like -1, 4.
So the vertex is the highest point.
Yeah, the vertex is the highest point on the graph. So vertex is at -1, 4. Period. Done with part A. B. B is, does it open up or down?
Down.
Oh, that seems like a really stupid question, right? Down, pretty sure. Probably, I think.
X-intercepts.
Okay, so C is x-intercepts.
If
No, that
there
would
was
be the
no
domain
graph,
range.
how would you,
Good question. If there's no graph,
how do you tell if it's
how
up
do
or
you
down?
tell if it opens up or down? What are you guys looking at? You're looking at the coefficient on the x squared term, right? The number attached to x squared, and wondering whether it's positive or negative. If it's positive, it opens up. If it's negative, then it opens down. That's from that 12.3 stuff, right? The negative makes a vertical flip. All right, so C is x-intercepts.
Yeah.
So the x-intercepts are
-3.
okay, -3 and 1. And if you want to phrase these as points, go for it. Why don't you need to?
Because it didn't ask.
They didn't ask for it?
Kind of, because I've said they're x-intercepts,
So
right?
you know it's 0.
That means the y-coordinate has to be 0. That said, if you're prone to mixing up which one is which, right, the x and the y, it might be a good idea to label them as points. So these points are 0 high, right? D is one of the y-intercepts. R? Is. Why is?
Intercept is.
Why is there only one?
Because it's a parabola.
Better than a parabola, it's if there were 2 dots on this vertical line, right, then it wouldn't be a
Then it
function.
would be a function.
So functions have one y-intercept, and on this one it is
3.
3, 0?
0, 3.
0,
3.
3. That's this point, right? It's over 0, up 3.
Yeah.
Okay. How about E? What's E asking?
Domain.
Domain and range, or E and F? Okay, so what's the domain on this one? All real numbers? How do you know that? Okay, we could think about doing the crocodile smash to this thing, or we could think to ourselves, it's a parabola and all the inputs work. Or we could look at a rule for a parabola if we had one, and we could say, okay, I can square stuff, I can add stuff together, I can multiply, all those operations are cool with all the numbers. How about F? What's the range? That's what I should say, is the domain here. The range is -infinity to, what's the top? What's the highest it gets? Oh, 4, the y value of the vertex, right? You guys see you don't need the picture for that?
Right.
You just need to know the y value of the vertex and then whether it opens up or down. Brackets?
Open, close.
Open, close? Cool. Good work. G? What's G?
X values.
Okay. X values for positive? What are the x values for when this function's positive? How about where is it positive? Can I circle that on the picture or something?
-3 to 1.
That's like this stuff, right? Okay, so if that's like that stuff, what are the x's?
-3
Bracket -3, bracket 1 to 1.
-3 to 1, and then the brackets depend on whether you think 0 is positive, negative, or neither. Okay. I'm going to call 0 positive today. I think your book calls 0 neither positive nor negative, so they'll always use opens on these. Whatever. Pick a convention and go with it. H comes after G, right? Seriously, I dorked this up anyway. Fine. So H is probably x values for negative.
Yeah.
Okay, so when is it negative? How about an easier way to say that? When is it negative? When it's not positive, right? So I should be able to say, right, this one should basically read the other stuff than was in G, right? Okay, so how do I write the other stuff than was in G?
Well,
Negative
infinity to -3.
Okay, negative infinity to -3,
And then
both open.
and then
1.
1 to infinity. Okay, those are open, and
Close.
yeah, it depends on whether you're counting 0 as negative or not, right? I'll count 0 as both, but again, I think your book throws opens on those. All right, what's the next one? Increase? Decrease. X values for decreasing. How many pieces are there here? Did I show you guys this technique? Put a little guy on here. How many pieces are important here?
2.
These two and maybe, yeah, maybe the top. You guys see that?
Okay, so it's 2.
So when is this, what's decreasing mean in terms of the little guy?
Going downhill.
When is he going downhill? So when's our little dude walking downhill?
-1 to 1.
-1 to 1?
Yeah.
Yeah.
Oh. Does he switch whether he's walking uphill or downhill here?
He gets -1.
Yeah, so he switches whether he's positive or negative, right? But he doesn't switch whether he's walking uphill or downhill. What do I do with the -1? What bracket goes on -1? Yeah, that's open because it's a transitionary point, right? At -1, he was increasing on that side and decreasing on the other. So he's definitely not decreasing there, right? All right, J is
Increasing.
increasing.
Yeah. X value.
So X values for increasing, and that's negative infinity to -1, open bracket. Really, that's the other stuff, right? So these guys should account for everything except maybe where stuff is 0, the positive and negative ones. These guys should account for everything except maybe where the thing's flat. You guys see that? If there was a big flat spot, what would I want to call that? Yeah, I'd want to say it's constant. You guys cool with this? That helps, Robert?
Yes, thank you.